Brian, I'm so sorry. I got called into a meeting on a Zoom call. I apologize for that. Thanks for sticking around.
Oh, no problem. It happens. I understand.
All right. So you want to try the world of LiDAR, huh?
I do. I think LiDAR is a cool technology, and I want to be involved at the ground floor.
All right. Well, you got your circuit board behind you. You're ready to go. Okay. So I guess you're coming in. I guess you're lucky enough to be at the beginning of your career, not your end of your career like me. So are you flexible in terms of your projects and interests? I think the position you're interviewing you for is like a new chips coming back, and we do our usual characterization and hopefully not debugging and get it off to production.
Yep.
So that's the world. And then these chips, I don't know if you got to look at what's inside our chips, but they're interesting in that they're, we call them like mixed mode. So there's like sensitive high speed analog stuff along with a digital core and a whole bunch of logic. So the
Hmm.
chips, their job in life is to like amplify a weak photocurrent signal and then give them a real high resolution timestamp to like sub nanosecond precision, and
Wow.
also does a bunch of the stuff for controlling the lasers, make a little like control loop. So that's great. And then it's like gee whiz, but from your point of view, it's going to be, oh boy, there's a lot of complicated stuff in a tiny little square that you can't even see inside. So that means you have to talk to it through your test equipment.
Yeah.
And so, kind of what your first challenges and projects would be is this is like the third chip in a little series of them. So there's unfortunately you don't get to do it all from scratch the way you'd like it. It means reading through disgruntled employee code from years ago and fixing it. No one's disgruntled here, but they do. People do, move on and things like that. So the code base is in Python. It's pretty
Nice.
clean um, in terms of like everything's like in nice columns, but then they didn't write any comments. So they're real good at like keeping everything in a straight line, but they're not good about like saying what each function does. So, but you're probably real smart and you'll read through it. But there's no like emulation environment, right? So you don't actually know that your code works until you go to lab and try it. And then if you get the bad answer, right, is it the chip or is it my setup or is it my actual
Oh.
code? Now, the expectation I think is going to be that you trust that code, but you're probably smart enough to know you don't trust anything in this world. So that's
Hmm.
kind of where it's at. And then the lab bench, there's going to be two branches. Like eventually, you're going to be interested in like the product that we get to sell and hopefully pay our salaries. But before that is the world of the test bench. We have, it's a nice lab. It's fairly clean, and then so your like environment's going to be Python on a laptop running Linux or Windows. It talks to like a FPGA board because Python can't do things fast enough. So it like sends a command to the FPGA board. Usually we use Xilinx. I think you'll find that interesting, and that's has to be programmed as well. That does like all the high speed sequencing to talk to the chip and grabs the high speed digital serial stream SERDA as output from the chips, and then passes that back to Python where a human being can look at it and makes the picture. And then we do that over temperature and all kinds of stresses on the chips.
Hmm.
And that typically takes a good couple months to get real good at it, confident. And then the chips then migrate. And then we have to do the same thing, assuming that all goes well. In parallel, we kind of get ready for the wafer test. So when you make ASICs or chips, you can you want to they don't work. So you actually have to test them on the wafer to do it economically. Because like when you test a chip on the bench, it's going to take you a few minutes, and you're involved. So if you look economically, that means to figure out if a chip's good or bad probably costs you $2 already or something like that. So the way people do it at industry is you have a robot do it, and it does it at the wafer level before the chips are even sawed up and packaged. So at that point, finding a chip and throwing it away is only a few cents. And that's how this stuff gets economical. So people want to do it. Because
Oh.
when we sell them to our user, we want to present these chips as that they cost us like $2 or something like that.
Mm-hmm.
And the like bare silicon that we get from the foundry is probably costs us like 25 cents. So between there and there is our profit plus all the other steps we need to make sure it's a good product. And then we don't sell the bare chips. We sell them as LiDARs. So then this chip goes to your co-workers who are like circuit board designs like you see in your screen background, where the chips get put on a board and connect to the photodiodes and the lasers and do all the magic for people. So one day, or not too long, you can start to, you can get more responsibilities and work with the circuit board designers and the chip designers to, make that whole process as efficient as possible and work on like feedback from customers as to what we do in the new chip. So we're a pretty small company. There's a lot of room. What I'm trying to say is there's room for growth as you get smarter.
Mm-hmm.
But in the beginning, you got to be happy kind of being a robot where you're going to be testing the chips. And then if they're bad, you're going to have to, do your best to see, did I do something wrong? But then work with the other chip designers and other engineers to say, like, why is it doing it? Is it's a problem in the chip, which nobody hopes, or is there something in our test vector? So in reality, what it means is we have to try, like, typically they're going to say, oh, try this or try that, because we make the chips very adjustable. It's one of those things where you can adjust it from bad to worse. And they're going to want to know, like, turn it from worse to bad. And then you'll be like, oh, look good.
Mm-hmm.
So, so at that point, I guess you won't, you probably helping me and other engineers, if you're interested in it, in developing the hardware that you'll be using it. But initially, your role would be really applying what we've all built, running the test procedures, maybe making changes to the code or making sure the code's good, and then presenting your results. And I think that's all stuff, even though you're early in your career, those are all things like you don't really learn all that in a book. You learn that by doing it. Mm-hmm. So, and behind it, you'll see like all the engineers are working hard on, designing circuits and things like that. You'll find that interesting. So you'll be exposed to, circuit board design, schematic capture, simulation, FPGA coding. That'll all be going on around you. So I think it's a good role to learn. So if that's all interesting to you. Now, it's not like wine pairing or any of the other big things you've been doing, but it's engineering, which sounds like you want to give it a try.
Mm-hmm. Yeah.
So that's my spiel. Maybe give me a little talk about why you're interested in engineering, if you like writing software, and maybe some of the projects you got to work on. Looks like you did a little microcontroller programming along the way. So.
Mm-hmm. First of all, I just want to start off with that. That was actually the most insightful explanation anybody's given me of the position so far. That was actually really well presented, and I feel like I have a much better understanding of the position as well, and the whole process.
No, thanks. Yeah, some people, live in a perfect world. When you get as, I'm more mature in my career, so, people build things up and they fall down, you make it better. It's very iterative in the real world. So,
yeah. So where do I begin? My senior design was a wireless EKG device. That was a team of 5. I was really responsible for the physical construction of that.
Not being like, oh, that's going to be a problem, yeah, that crap may be good. It tastes good, yeah, but it's like, yeah, no. I don't see how anybody could do that, to be honest with you. That's just, wow. But people do, sadly. Trying to figure out. Oh, trying to connect. There it goes. Yeah, I was trying to get Uncle Dan's Bluetooth speaker going, and it's weird. Um, Several times when he's been running his music and when I've been running my music, so that's why I know it's a speaker, right? It's not just our phone, but the music will start stuttering, like as if it's having trouble, you know, buffering, right? And only it's weird because it's not, usually when I have trouble buffering, it actually stops, right? And then waits until it buffers and then keeps going, right? It doesn't usually sit there and go, like that, right? So I couldn't figure it out on this time, and I think I just figured it out what it is. It's the speaker itself is having a conflict. Basically, whenever there's more than one phone Bluetooth to it, I think it's hitting priority conflicts, and it starts doing that. Because I realized whenever it did it to Uncle Dan, I was usually around, and my phone was probably trying to tie into it, even though I wasn't trying to use it, right? And I've noticed that since I've been using it this week, and flipping it between my two phones, the Rebel and the Moto Z, right? It started doing the same thing to me, and I'm like, I don't know, and the only thing I could think of was, well, maybe it's because they're both paired to it, or both connected to it at the same time, and so I started disconnecting. When I go from one phone to the other, I disconnect the phone that I'm shutting down entirely, and it hasn't happened since. So I don't know what it is, because it shouldn't have that issue, but for whatever reason, I think it's probably because the speaker itself doesn't know for shit. It's not a smart electronics per se. It's kind of a semi-smart, right? But ultimately, I think probably more what it is it doesn't know how to handle like when a phone's connected to it, it probably periodically pings the speaker just to connect maintain the connection or something, right? And somehow that pinging or whatever is interrupting whatever connection it's dealing with right now or something like that. All right, what happened to this? But yeah. Oh, nice. What kind of band is he in?
Would have sold me on it.
So one of the things I'd like to just make sure of is, and I think since you worked with the public, you're probably very good at this, but how do you deal with difficult, impatient, very motivated, but sometimes self-blinding people? So we have engineering's full of like firstborn children of privilege who really want to get where they're going and crush all the people in their way. So, do you mind helping them, or do you want to like sabotage them, or you don't really care? You just want to be like part of the team and get where everyone's going. Not that that happens in Velvet all the time, but I think I guess the company is always in a hurry, and you'll be working like on a critical part.
Mhm.
So you kind of have to just like suck it up and do your best. And even if people ask you to do things that seem like a bad idea to you at your stage in your career, you're probably, I mean, it's okay to like say, what about this way? Or why are we doing that? But
Mhm.
in the end, you're going to have to kind of defer their judgment. And I want to avoid workplace violence situations. It's like number one in my priority.
It's funny you say that because I think I took it off my resume to make space, but uh, I was the manager of the winery, so that was handling a lot of high-end customers who are, for lack of a more polite word, very entitled. I came here and I spent this amount of money. Do you have any idea how much money I spent here? How important I am? I deserve this. So there's a lot of resolving conflict with them because we obviously still want to keep them around. These are people who spend a lot of money here. Um, but also chefs themselves, because I was on the pairings side, so I was organizing the pairing and I was working between the chefs and the.
Right. Nice. But all right, so you have a great afternoon, man. Love you. Bye. All right, what the heck is going on with this little thing? It's not hard rocket science. What the hell?
I also did security for a couple of years at a hospital, so I.
Always working with that version to get everyone on the same page.
Yeah.
Maybe you've done that already, or maybe it'd be new to you. It's not very hard. since looks like you've done all
Oh,
that stuff.
yeah, I got a wireless one. It's gas powered, goes off butane, and has different attachments on the end. It's super
Oh, I think
cool.
you'd like the job. Yeah, give it a try. Give it a try.
Oh yeah, I'm looking forward to it. Uh, sorry, you mentioned moving from Sacramento to the Bay Area isn't a great idea. What's the alternative for somebody in my position? It seems like all of the jobs are in Silicon Valley area.
Oh, right. No, I mean it depends on. I think all I'm trying to say is that the Bay Area brings a lot of people. It's a finite space, so
It's expensive.
compared to your like privacy and things up in Sacramento, you're going to find it crowded and expensive. But
Yeah.
at the same time, you'll also be around a lot of young people, and you maybe make friends and things like that. So
hmm
just but I'm sure you've grown up in this area. You know what the Bay Area is like. But I mean,
Yeah.
rents are very high, and so just plan it all out. So make sure it's something you really want to do, because
I mean,
that's
what's the
something.
alternative? There's no other options. I got to get into the field. That basically means moving down there.
There's stuff up in Sacramento, but
Mm.
nah. I gave it a try. I'm supposed to sell you on the job. I just want you to know what you're getting into. That's it.
Yeah. No, I've been thinking about
But
it.
but we're in South San Jose, so actually Santa Cruz isn't too far, and living a little bit south of San Jose might be nicer, like Gilroy and Hollister and things like that. That's an easy
Yeah.
commute,
Some of
things
the
like that.
reverse commute or yeah.
And then, but I think the whole Bay Area you'll find it probably interesting. So at least for the first years. But a lot of people, they're very like, a lot of people already have like families and they want, space for it. And then they complain about the housing prices because
No.
nobody's.
I want a studio. I've always wanted a studio.
Right. Yeah, and then we do have like some people. I mean, the nice thing is we do have a pretty good spectrum. I mean, we're biased more towards younger engineers. So a couple of people come all the way from San Francisco. Some come from Santa Cruz to get to work, and the work is. I mean, the nice thing is it's all the management. We're getting a little bit more structure now, but the boss for a long time was just very hands-on engineer, nice guy, and you can kind of make your own schedule as long as you're
Getting
taking
work done.
ownership of the work.
hmm
It's a little different than the winery where you had to be there when they were open and wait till the last person wanted to leave.
Yeah.
Long hours.
Yeah, it was.
So how did everybody else treat you? Did give you respect and all like that? Because sometimes they're mean to new grads. So.
No, everyone's actually been super nice. Everyone's been so supportive because, full disclosure, there's been a few questions and I'm like, I don't remember that. I can't answer that right now. And everyone's like, no, that's okay. We understand. Everyone's been very understanding and cooperative. Everyone gets that I'm a new grad. I don't have a lot of the experience. Some of the questions I'm getting are things that I haven't learned yet, but everyone's been really kind about it, and I appreciate that. Especially with these long interviews, starting from 8 and going until almost 1. I was nervous. This was my longest set of interviews ever. So I was like, oh, I don't know if I can keep this up for 5 hours.
You're doing great. You're doing great.
I appreciate it.
All right, Ryan, I'm going to let you get ready for your next interview. I think it's Pravin. He's a real nice guy. He's on the ASIC team.
Okay.
So, but he'll just see your background and he'll be like, oh, he looks like he can help. So,
I hope so.
and then, questions you can ask him are, how do you get all that analog and digital stuff to work well in one chip? And then you can turn the tables on him and start interviewing him. No, I'm just kidding.
I'll keep that one in my back pocket.
Yeah. Yeah. He's going to want to know that you're comfortable around a lab bench, that you can be a team player, and that you love reading software. It's like your favorite thing to do. So.
Definitely.
Who doesn't? Who doesn't? All right.
Oh, gosh.
All right. I better run, Ryan. You have a great day, sir.
All right. You too. Thank you.
Bye-bye.
Bye.